So now we are going to talk about, that is, we have already like talked about what is a vector and the properties of vector and everything. And now we are going to, and the types of vector also. That is one homework I have given, that I remember, still remember. That is one homework that I have given, that is types of vectors, and you must have seen all the types of vectors. And now let me ask you, like let me tell you something, that is two forms of vector. Two forms in the sense we can represent all the vectors into two forms. Any vector you can represent in two forms. First one, coordinate form, and second one, polar form. And polar itself, it is very clear from the word itself, that is polar means that is something related to angle and all. Coordinate means something related to coordinates. So for a three-dimensional vector, you will study this in detail in mathematics. So in a three-dimensional vector, you know that the unit vector along x-axis is I cap, and along y-axis, this is y, x, y, this is j cap, and along z-axis, it is k cap. Okay, I cap, j cap, and k cap, and this is the origin. Okay, so we represent in the case of coordinate form, we represent, suppose the vector A, which is in the space somewhere here. So A, I can write xi cap plus yj cap plus zk cap. So this is the vector format in the case of coordinate form. So what does that mean? Which means the vector A is actually xi in along the x direction, along the I cap direction. The value is xi, then yj, then zk. Okay, so this is the first important thing you have to note down, and this is what is the thing. Okay, and how do we find out the magnitude of this one? The magnitude, vector magnitude, is equal to root of x square plus y square plus z square. Okay, and what about the unit vector along A? That is, unit vector along A is equal to vector A divided by modulus of vector A. So which is equal to xi cap plus yj cap plus zk cap divided by root of x square plus y square plus z square. And you know that how do we find out the magnitude? The magnitude is like x. Suppose it is, you can consider, suppose here is a point, that is x, y, z. You know that it is xy, this is the xy plane, but you don't think that it is an xy plane. It is a three-dimensional. It's somewhere here. Okay, three-dimensional. So the distance from the origin, that is what is the magnitude, right? So root of x square plus y square plus z square. Okay, so this is what is the coordinate form. Okay, I think you got the idea about coordinate form, and solve 2-3 problems, then you will get it. So question number 1. Okay, question number 1. Vector A is equal to 3i minus 2j plus k. Okay, so then find out modulus of vector A. Then what is A cap? That is unit vector along in the direction of A. Both the things you have to find out here. And question number 2. Vector A is equal to 3i I cap plus 2j cap plus 6k cap. Again find modulus of vector A and A cap. Okay, both of you do both of the problems. You gotta do it, and right now you do it right now. And then I'll discuss them later. Okay. Okay. So I think you have got a chance to solve the problem. I think you must have paused the video and then you solved yourself and you came back. So let me solve it myself. Look at this. Okay, first one. This one. So what is the modulus of vector A? Modulus of vector A is equal to root of 3 square plus minus 2 square plus k 1 square. So 3 square plus minus 2 the whole square plus 1 square. So which is equal to root of 9 plus 4 plus 1, which is equal to root of 9 plus 5, 5 plus 9, 14. So the value is equal to 14. So root 14 is the value. And what about the a cap? A cap is equal to vector a divided by modulus of vector a. Okay, which is equal to, what is vector a? 3i cap minus 2j cap plus k cap divided by modulus of vector a, that is root 14. Very simple. This is the answer. Look at this, very simple it is. So this is what is the a cap, the unit vector along in the a direction. So second question you have to solve yourself. Now you got the idea. Now you have to solve it yourself. Okay, thank you.